At just 3,113 pounds, the Cybercab is an impressive 700 pounds lighter than a Model 3. It uses an ultra-compact 47.6 kilowatt-hour battery pack, while still achieving an outstanding efficiency of 6 miles per kilowatt-hour, thanks to Tesla's first-ever 219 horsepower front-wheel drive motor and a laboratory-tested range of up to 418 miles. Tesla has now officially published the Cybercab's technical specifications on X, replacing months of speculation with verified information. More importantly, the company has completely reworked the Robotaxi's safety architecture and emergency systems, allowing it to function as a fully autonomous vehicle without a steering wheel. But why, at this particular stage, did Tesla decide to redesign the Cybercab's entire safety system? The reality is that much of the public conversation surrounding autonomous vehicles assumes artificial intelligence will eventually eliminate virtually every traffic accident. Tesla's documentation presents a much more practical view. Even highly advanced autonomous systems can still encounter rare collisions, meaning passive safety technologies that protect occupants after an impact remain an essential final layer of defense. One of the most important upgrades addressing this issue is the active hood system. During a pedestrian collision at speeds between 15 and 32 miles per hour, or approximately 25 to 52 kilometers per hour, the system automatically raises the rear portion of the hood. This creates additional deformation space, designed to absorb impact energy, and helps prevent a pedestrian's head from directly contacting hard mechanical components or the metal structure underneath. This engineering approach is strongly supported by worldwide road safety statistics. According to the World Health Organization, approximately 1.19 million people die in road traffic accidents every year, with more than half of those deaths involving vulnerable road users, including pedestrians, cyclists, and motorcyclists. At the same time, despite being a compact two-seat cabin, the Cybercab contains as many as 10 comprehensive airbags. These include front airbags, knee airbags, curtain airbags, as well as inner and outer side airbags. This configuration addresses an important difference between a robotaxi and a conventional vehicle. Passengers in a traditional driver's seat generally maintain a predictable position, while Cybercab passengers could recline, relax, read, or work. As a result, the safety system needs to protect occupants across a much broader range of possible seating positions and impact angles. In the United States, preliminary statistics indicate that more than 39,000 people continue to die in traffic crashes every year. That demonstrates why multi-directional airbag protection remains an essential safety barrier, regardless of how advanced autonomous collision avoidance becomes. Beyond protecting passengers, Tesla has also developed highly detailed emergency assistance features specifically for first responders. These capabilities are clearly described in the newly updated emergency response documentation. The vehicle contains 2 independent emergency cutoff loops located in separate areas. One is positioned underneath the front hood, while the other is located behind the passenger side B-pillar. This ensures that if one section of the vehicle is severely damaged during a major collision, firefighters can still reach the other location and quickly isolate the Cybercab's 326-volt high-voltage electrical system. If the vehicle becomes disabled in a dangerous situation, rescue personnel can use dedicated mechanical controls installed onboard to move the vehicle manually. This replaces the conventional gear selector found in vehicles equipped with steering wheels. Inside the cabin, each door has 2 separate release methods. There is a normal electronic button intended for everyday use and a manual pull lever that can be used if the vehicle completely loses electrical power. Tesla has also centralized all window controls directly beneath the main display. This makes them easier for passengers to find during a stressful emergency, instead of forcing them to search unfamiliar door panels. Another notable feature designed specifically for the autonomous camera system is an integrated compressed air reservoir connected to an automated camera cleaning system. It can remove dirt, mud, road salt, insects, and other contamination from the camera lenses, helping the sensor suite maintain clear vision during long commercial fleet operations without requiring a person to manually clean the cameras. So how does Tesla expect the Cybercab to manage emergencies without a human driver? The answer begins with the autonomous system's official classification as SAE Level 4 Automation by the Society of Automotive Engineers. This means the vehicle assumes responsibility for the dynamic driving task within its defined operational design domain without requiring human supervision or intervention. To make this possible safely, Tesla has developed specific processing rules for unexpected situations. For example, if the system detects that a passenger has unfastened their seat belt or is attempting to open a door while the vehicle is moving, the Cybercab immediately cancels its autonomous route and performs a controlled stop, pulling over safely. This prevents a passenger from accidentally stepping directly into a lane occupied by approaching traffic. If the vehicle encounters a critical hardware malfunction or loses communication with its radar and camera systems, the system automatically activates the hazard lights at a high flashing frequency, directs the vehicle toward the nearest safe parking area, and sends a distress signal to Tesla's support center. The vehicle is also designed to recognize the lights and sirens of emergency vehicles and automatically yield the right-of-way in accordance with traffic regulations. Energy management is handled with the same proactive philosophy. The Cybercab continuously calculates expected energy consumption based on the planned route. If the system determines that the remaining battery charge will not be sufficient for the next assigned trip, it can stop accepting additional passenger requests and automatically navigate toward an inductive wireless charging station. That system is officially rated at more than 90% charging efficiency, allowing the vehicle to replenish its energy before returning to commercial service. Taken together, the information contained in Tesla's regulatory documentation shows that the Cybercab is far more than an electric vehicle with its steering wheel removed. Tesla is developing a closed-loop commercial transportation platform in which passive safety equipment, emergency response procedures, and software-based risk management are carefully designed to operate safely across millions of real-world miles. But how will the Cybercab communicate and remain safe when unexpected emergencies occur? One of the most overlooked details in the newly released documentation is that Tesla has gone well beyond simply teaching the vehicle how to recognize lane markings. Instead, the company has designed the Cybercab to communicate directly with the people responsible for handling emergencies on public roads. This addresses a basic reality of real-world traffic. Roads are not controlled exclusively by permanent signs, traffic lights, and lane markings. To deal with these unpredictable situations, Tesla has equipped the Cybercab with an external microphone and speaker system built directly into the B-pillar. This equipment can establish a live two-way communication channel with Tesla's Robotaxi support team, allowing first responders to communicate with an operator through the vehicle's exterior speaker. This feature directly addresses one of the biggest psychological concerns surrounding autonomous transportation. According to a survey conducted by the American Automobile Association, as many as 66% of drivers say they are afraid to ride in autonomous vehicles because they believe they would lose control during an emergency. The rescue documentation also states that on-duty emergency personnel can wear their official uniform and present their identification badge to the camera located on the B-pillar. The system can then authenticate their identity and provide requested privileges such as manual control, override, or remotely lowering the vehicle's windows. Even more interesting is the Cybercab's ability to understand manual gestures from traffic authorities. Tesla says the Cybercab's AI can interpret hand signals from police officers and emergency workers while also navigating temporary paths created with traffic cones or construction barriers. This capability is extremely important because temporary road work creates constantly changing traffic conditions. Estimates from the U.S. Federal Highway Administration indicate that work zones affect millions of drivers every day, while crashes occurring in these areas result in hundreds of deaths annually. Traditional navigation systems generally assume that road rules and infrastructure remain stable. The Cybercab instead relies on a neural network architecture capable of continuously processing real-time changes, including blocked lanes, construction zones, or an overturned vehicle obstructing the road ahead. If the vehicle encounters extreme weather or an operational condition that exceeds its predefined processing limits, the system can immediately send an alert to the centralized management center. Tesla's focus on operational safety is also demonstrated by a manually accessible emergency charging cable release located behind the rear wheel arch liner. If the inductive charging pad or charging connector becomes mechanically stuck, technicians can physically disconnect the cable without damaging the vehicle's electrical architecture. Tesla has also specifically required the battery coolant to have a distinctive orange color. Although this might appear to be a small detail, it serves an important purpose. During an emergency extraction or cutting operation, rescue crews can immediately distinguish the cooling system associated with the 326-volt high-voltage battery from normal vehicle fluids. This helps reduce the possibility of electrical shock or accidental fire during rescue operations. So how does the Cybercab achieve continuous 24/7 autonomous operation? The answer can be found in the comprehensive commercial network strategy described in Tesla's regulatory documentation, rather than in short-term pilot programs. Tesla defines the Cybercab's operational design domain broadly, covering a wide range of public and private road environments. These include city streets, highways, rural roads, private roads, parking structures, charging facilities, and designated passenger pickup and drop-off areas. The vehicle is designed to operate reliably during both daytime and nighttime conditions, including light to moderate rain, fog, and light snowfall. However, Tesla is not attempting to force the Cybercab through every possible weather condition. Instead, the company appears to be following a conservative risk management approach similar to the philosophy used in aviation. When severe weather is forecast, the Cybercab can automatically stop accepting new trips. If a severe storm unexpectedly develops during a journey, the vehicle can proactively pull over and move to a safe location. This fleet management approach could provide significant economic advantages compared with conventional private vehicle ownership. To make the difference easier to understand, the following data comparison highlights the major contrast between traditional vehicle use and autonomous fleet utilization. But why did Tesla create the Cybercab on a completely new platform instead of simply modifying the Model Y? One of the most important details revealed in Tesla's latest Cybercab documentation is that the company did not simply remove the steering wheel from a Model Y and turn it into a Robotaxi. Instead, Tesla developed the Cybercab around an entirely new vehicle architecture designed from the beginning for autonomous transportation, lower manufacturing costs, and large-scale fleet deployment. This strategy separates Tesla from many other autonomous vehicle developers that continue modifying existing passenger vehicles instead of creating platforms specifically designed for robotaxi operations. One of the biggest engineering differences can be found underneath the floor. Tesla confirms that the Cybercab uses a structural battery pack similar in concept to the technology introduced with the Cybertruck. In a conventional electric vehicle, the battery primarily functions as an energy storage system. A structural battery, however, becomes an actual part of the vehicle's chassis. This can significantly increase overall structural rigidity while eliminating unnecessary supporting components. Even more importantly, the Cybercab seats are mounted directly onto the battery pack instead of being installed on separate floor structures. This approach reduces the number of individual components, lowers the vehicle's overall weight, simplifies the manufacturing process, and improves production efficiency. Tesla has repeatedly promoted the philosophy that the best part is no part, and the structural battery is a perfect example of that idea because one component can perform several different functions at the same time. And that is what makes the Cybercab so different from a conventional electric vehicle. Tesla isn't simply removing the steering wheel and adding autonomous driving software. The company is designing an entirely new transportation platform around safety, efficiency, emergency response, and large-scale autonomous operation. The real question now is how quickly Tesla can take everything described in these documents and turn it into a reliable, commercially scalable robotaxi fleet operating on real-world roads. What do you think about Tesla's Cybercab? Could this purpose-built design become the foundation of a massive autonomous transportation network? Or do you think there are still major challenges Tesla needs to overcome before fully driverless operation becomes practical? Let us know what you think in the comments below. If you enjoyed this video, make sure to hit the like button, subscribe to the channel, and turn on notifications so you don't miss our next Tesla update. Thanks for watching, and we'll see you in the next video.